Hi everyone. So this part of the video lecture is just to sort of illustrate how you can do these correlational analyses like bar graphs and tabular analyses in Excel. So the first one that we have, let me just walk you through this data set real quick. So this is every state. In fact, let me just quickly sort these back to how I want them, just so you can see. This is every state alphabetized and whether it belongs in the South. So this is our first variable, whether it belongs in the South. 1 is it's in the South. 0 is it's not in the South. The second one is religiosity. So this takes on 3 values. 1 means it's not religious, 2 means it's moderately religious, and 3 means it's highly religious. So Alabama is highly religious, whereas Alaska has low levels of religiosity. The next one is the percent of people, and this is from Pew in 2014, the percent of people who identify as pro-choice, who think that abortion should be available in most or all cases. So Alabama, 37% are pro-choice, Alaska, 63%, Connecticut, 67%. And then finally, we have the vote margin for Mitt Romney in the 2012 presidential election. So again, these are percentages. So things like 37% of Californians voted for Mitt Romney, whereas 60% of Alabamans, something like that, vote for Mitt Romney. Now, if you recall from our video lecture, you need to do different analyses if you are going to, depending on what kinds of variables you have. So here, our variables, we have, like if we were to categorize these, South is a categorical variable, takes on a value of 0 or 1. Religiosity is an ordinal variable because the unit differences between 1, 2, and 2 and 3 are not the same, but there is very clearly some order to it. Low religiosity, high religiosity, moderate religiosity. And then these two, percent pro-choice and percent vote for Romney, are continuous variables. So if I wanted to do let's say that I was testing whether pro-choice attitudes affect vote choice in the 2012 election, here I would probably do a scatter plot. If you recall from our video lecture, make sure to review that if you don't quite remember. If you recall from our video lecture, if you have an independent variable that's continuous and a dependent variable that's continuous, chances are you are going to want to do a scatter plot. You're going to want to do a scatter plot. So here, what I would do is I'm going to highlight these two columns, percent pro-choice and percent Romney. And I'm going to go to the Insert tab, and you'll see here that I have a little button in the middle called Recommended Charts. So this is on a Mac computer, an Apple computer, but on a Microsoft computer, you should have a similar button called Recommended Charts. And Excel is pretty smart. When I click on this Recommended Charts button, the first one that it comes up with is a scatter plot. So I'm going to choose that. So if I look, moving the plot around, so here we can see that the percent of voting for Mitt Romney is along the y-axis, since that's our dependent variable, and the percent pro-choice is along our x-axis, since that's our independent variable. And you can see here that really there is a pretty strong relationship, a strong correlation, in that they do seem to be going together. So when percent pro-choice is quite low, right? So in other words, many people in the state oppose abortion. What we see is really high levels in the 60s and 70s support for Mitt Romney. So 60 to 70% of that state voted for Mitt Romney. By contrast, if we look over here, if 60 to 70% of the state are pro-choice, the percent of people who support Mitt Romney has dropped. In other words, here we see a strong negative correlation between pro-choice attitudes and the percent who support Mitt Romney. Okay. Now, if you had instead, this is what you would do for two variables, an independent and dependent variable that are continuous, but what would you do if you had one variable that was categorical? So let's say our independent variable is categorical or ordinal, and then our dependent variable is continuous. You wouldn't be able to do a scatter plot. It wouldn't make sense with categorical and ordinal. Instead, what we're going to want to use is a bar graph. But first, what we need to do is calculate the average of our continuous variable for each of the categories in our independent variable. So here, the first thing you would do is go to your data tab. So you should have a tab up here, home, insert, draw, page layout, formulas, data, and then choose filter. See this little button here? It looks like a funnel, this filter button. And what you're going to do is we want to sort by our categorical or ordinal variable. So here I want to look at the average level of support for Romney for states that are not religious, moderately religious, and very religious. So what I'm going to do is I want to group these states according to their religiosity. So here what I'm going to do is I'm going to click this little arrow in the bottom right-hand corner and choose ascending down. So here you can see that these are all of our states that are not that religious, going from Alaska, California, Colorado. Then the twos here are our moderately religious states: Arizona, Delaware, Iowa, Maryland, Michigan, so on and so forth. And then finally we get down to our religious states: Arkansas, Georgia, Idaho, Kansas. Now, what we would do, I would probably make a little note for myself. I'd say low religiosity, moderate religiosity, and high religiosity. And then I would get the average for each of those. And you can do that, you can do that by hand and average all of these numbers, but they also have some really nice functions in Excel, like the average function. All I'm going to do is type in here equals average. You can see it wants me to use average. So I'm going to click on average and then open parentheses, and I'm going to highlight all of the states that have low levels of religiosity and their vote share for Romney. Okay, so you notice that I highlighted from Alaska to Wyoming, okay, in this section. For moderate religiosity, I'm going to do the same thing, equals average. And then I'm going to highlight all the states that are the two values, okay? So all the way from Arizona to one more, Wisconsin, and then I'm going to close parentheses. Then I'm going to finally do it for high religiosity. So I'm going to do equals average again, open parentheses, and I'm going to take all of the states and their vote shares for Romney, just clicking on and highlighting them, and close parentheses. So here you can see that the vote share for states with low religiosity, the vote share for Romney is about 43%. For moderate religiosity, it's 48%. For high religiosity, it's about 58%. Now, we still don't have our bar graph yet, but what you can do is just highlight this, go back to our Insert tab, Recommended Charts, and look right here. Look at this. The first thing it recommended was a bar graph, right? And we can see along here the percent that they supported Romney, the average support for Mitt Romney by religiosity. And it looks pretty nice too, right? High religiosity, moderate religiosity, and low religiosity. And very clearly what we can see is that the more religious a state becomes, the higher the vote share for Mitt Romney. Now we can also do something like this for the South, okay? So this was an ordinal variable, but we could also do the same thing for the South. So I would here put non-South and then South. I would sort these states. Again, we already have our filter button on, but if maybe you turned it off, you just click on the data tab and then click on this filter funnel button, okay? And then we click this arrow and we click ascending, right? And so that has changed all of these, right? It changed them, so now they're sorted. I'm gonna delete this to give us a little more room. It's gonna change all of these. So now we have our southern states down here, Florida, Oklahoma, Virginia, West Virginia, Alabama, Arkansas, Georgia, Kentucky, Louisiana, Mississippi, North Carolina, South Carolina, Tennessee, and Texas. So here we want to see what the vote share for Romney is in non-South states. So again, I'm just going to do equals average and open parentheses and highlight the vote shares for all states that are not in the South. Okay, then close parentheses. 47%. And then all states that are in the South, we're going to do the same thing, equals average, and highlight all these southern states. Oops, don't want to get that last one. And you can see that in the South, about 57% of voters supported Romney, whereas in the non-South, it's closer to 47%. Now, again, if we want to we're going to want to make a bar chart of this. So I highlighted the cells that I'm interested in, and I'm going to do Insert, click on Recommended Charts, and look here. The first thing that comes up is a bar. And what we can see is that about 47% is the average for states in the non-South, and then the South is quite a bit higher at about 57%. And you can edit these parts too. I can say vote share for Mitt Romney in, oh, gotta spell his name right, in 2012 South versus non-South. Okay, so this gives you an idea of how to do both scatter plots and bar graphs, okay? This gives you an idea how to do both scatter plots and bar graphs. The next thing we're going to do is check out how to do tabular analyses, okay? So I'll see you over in that Excel spreadsheet next. So here is our second data set, and you can see here, this is our first variable in this data set is the state name, just like we had in the first data set. The second variable is the location, the region that the state is in. So specifically, this is a South categorical variable. So Alabama is in the South, Alaska is not in the South, right? Arkansas is in the South, California is not in the South. And we did that for all 50 states. Medicaid expansion is coded as not expanded, which I think is pretty intuitive, right? This state has not expanded Medicaid, and then this state has expanded Medicaid. So Alaska has expanded, Arizona hasn't. Arkansas expanded, but Florida hasn't. Now, what we're going to do is we're going to do a tabular analysis because both of these variables are categorical or ordinal. In this case, both are categorical. South is categorical, as is the Medicaid expansion. And if your independent variable is categorical and if your dependent variable is categorical or nominal or ordinal, then you should do a tabular analysis. So the really nice thing is that Excel already has a function to do this, and it looks complicated at first, but is actually quite straightforward. And if you just follow along with the steps with me, then it should be pretty straightforward. And this tool is called a pivot table. Now, what you will do for a pivot table is select the triangle. The first step in doing a pivot table is selecting all of your data. And to do that, you can just click on this little triangle. Click. The next step is to actually sort of choose the pivot table. And in order to do that, you click on the Insert tab, right? For me, it's right next to Home. Home, Insert, and then we'll do Pivot Table. Did you see that? So Home, it's in the tab Insert, right next to Pivot Table. And this little pop-up box comes up. Because we've already selected all of our data, we don't need to really mess around with any of this, okay? I don't want you to change any of the options. If you've already clicked on that triangle and selected your data, then you don't need to do anything with this. The other option here is to choose where to place the pivot table. I do not advise putting it in an existing worksheet. Instead, stick with the default of the new worksheet. What I'm going to do is press OK. And you'll notice we're now in a new, fresh worksheet. Here's our old one, sheet 1, and here's our new one. I'm just going to zoom in a little bit more so we can see a little better. So here, these are all of our pivot table options on the right. So filters is on, this is the first option. We are not going to be messing with filters today. Just leave it. Don't touch it. Columns is this next one. Remember, our independent variable goes in the column. Rows is the next one, and then values is the final one. And today we're going to be using columns, rows, and values. Now, again, I'm going to say it one more time. We want to put our independent variable into the columns, and we want to put our dependent variable into the rows. So here, what I'm going to do is choose South, and it, for some reason, just wants to put it into the rows. But remember, our theory here is something like states that are in the South are going to be less likely to adopt the Medicaid expansion. So here, because South is our independent variable, and then our dependent variable is the Medicaid expansion, we're going to put this South variable, and all I did was click it and then drag it to where I want it to go, up in columns. So because South is our independent variable, we want to put it in the columns. Our dependent variable is Medicaid expansion, and we want to put that in the rows, right? Dependent variable is rows. Now you can see here, this looks pretty nice already. It says non-South, South as our column values, and then expanded or not expanded as our row values. Now we don't have numbers just yet, but that's actually really easy to do. Typically, my preference is to put, in order to get those numbers to populate here, we need to put something in the values. And in order to do so, I like to put the dependent variable there. Typically, you're going to want to put your dependent variable in this values box. And so here we can see that 32 states in not the South expanded Medicaid and 4 didn't. Whereas in the South, 6 have opted to expand Medicaid and 8 have opted not to. So based off of this, I think it's pretty clear. The states in the South are less likely to adopt the Medicaid expansion than states that are not in the South, right? We know that because, look, more than half of the states in the South have not opted to expand Medicaid, whereas more, like a lot of states not in the South, right? We're talking about what? 85% here have opted about about 83% have opted to expand, right? We could even do this table really in terms of percentages. So if you recall from our example in the lecture, we can make a table that looks something like this. So here we have 32 divided by 36 times 100. About 89% of states in not the South have decided to expand. Let's do this for all of them. So this is the number of states that have expanded. 4 divided by 36 times 100. Oh, that is not the number 100. That's the number 11. 6 divided by 14. All we're doing is taking this number and dividing it by this number. Times 100 equals 8 divided by 14 times 100. And then finally, we could have an overall one here. That's something like equals 38 divided by 50 times 100 equals 12 divided by 50 times 100. So what we can see here, these all add up to 100 along the bottom, is that in the South, about 89%, or in not the South, 89% of states have decided to expand. By contrast, in the South, only 43% have decided to expand, whereas 57% have decided to not expand. In other words, I think it's pretty clear that states in the South are less likely to adopt the Medicaid expansion. In other words, we do see a correlation here between the geography of the state, whether it is in the South or not, and whether it has expanded Medicaid. Now, I know that this is a lot of Excel work that I've shown you today, but it's such a useful skill to have. And I would be really excited to help you out with whatever project you're working on. If you need help with Excel, I would be happy to do that with you. So if you have questions about how this all worked and how it might apply to your own project, just touch base with me, and I'd be happy to provide assistance. Okay?